were three production lines, which are production line 1, production line 2, production line 3. Each of these lines is independent. This one reactor starts to the innermost as a production line. These three are independent, three production lines. Let's take this line as an example, going into more detail for everyone.
You can see, first of all, this is one of our conveying equipment. You can go forward, and then you can see this is one of our conveying equipment. That is to say, the material from the first floor, after crushing through our conveyor, fully automatic transportation to our reactor. This is our first process, crushing and lifting. This is one of our chemical material axes, and then you can see the chemical material axe A. Then the material into our chemical axe to be heated. Take a look at the combination of these valves. You can feel close. Is there a temperature? Because it is heating. This is the steam manual control valve. This is the steam pneumatic shutoff valve. This is the steam pneumatic control valve. It is the three valves and our pressure gauge and temperature gauge combination, and then control the temperature and cooling process. And then when the temperature to 100 degrees, these two valves are automatically combined and then produce a chain effect for heating. And now the mixing is running automatically, and then the pressure gauge and the temperature gauge are feeding back. This is our pressure. It's doing a real-time feedback. The second step is this saponification, which is our now a more important function, saponification. That is, how do we avoid biological cross-contamination? Just now, Mr. Cow also introduced the bile paste is a kind of complex rather than a pure product. Then we saponize it at high pressure and high temperature. This is the first step to fully kill the effective bacteria and avoid cross-contamination. The second step to fully combine the bile acid into free bile acid. The third step after full saponification of all the pig deoxycholic acid, pig bile acid, goose deoxycholic acid separation. The host can look at this as one of our chemical kettle, and then this is one of our manufacturing kettle. That is to say, the more the kettle is, the cleaner. That is to say, to avoid cross-pollution, kettle function is very clear. Our chemical kettle, 316 stainless steel material, and then the whole volume rate is 12.5 cubic meters. This is the first step because the material is very important. The second step of all the reaction kettle internal stirring and heating method is that we give the manufacturer independent cooperation. That is to say, to do the patented, because our reaction axe is a strong alkali dissolution process, because our bile paste is an acidic, p-value of 3 to 4, only through the strong alkali. It can only be dissolved by strong alkali. Why is its agitation designed independently? Because in the process of dissolution, it is a solid state first, then solid-liquid coexistence, then liquid state, which will produce a lot of torque in the middle. Our heating method is an external exhaust pipe and bottom exhaust pipe. Why this design? That is because he does not touch the material even if the problem occurs. 1 is not in contact with the material. 2 is no residual material, which avoids cross-contamination. And then the third step, to get a concentric azeotropic in the bottom of the outer exhaust pipe, at the same time after heating the temperature to reach a consistent, effective bile, acids will be dissolved, impurities will be sucked out. And then after the first floor, we just saw the filter, after the liquid into our saponification kettle. After the filter, after all the effective bile acids in the form of liquid into our saponification kettle. Saponification kettle, we abandon the traditional room temperature and pressure. The time is 10 to 12 hours. All the bacteria will be killed because this is our unique design, but also in line with national standards of the production process. In this case, this step will be fully complex bile acid into a free type from a point of separation, pig bile acid, pig deoxycholic acid, and goose deoxycholic acid. These 3 points, this is our saponification of a purpose. The traditional saponification time may be 40 hours, 50 hours, you see. Now we have high efficiency. Now 10 to 12 hours to complete the saponification. This is our independent function. From the chemical kettle to the saponification kettle is a closed pipeline connection. And then this is an inlet. You can see this side of a test clock, and then the material is turned up from the top, that is this side of the filtration, and then pumped up into our saponification kettle. The whole process is a fully enclosed. The entire pipeline are stainless steel. Equipment pipeline to avoid the risk of cross-contamination of This is our powerful separating kettle, which is the most efficient. And now we are 10 to 12 hours to complete the saponification. This is our independent function. This is our powerful separation kettle. You can see that this separation kettle and the previous 2 kettle configuration is not the same. That is the valve belonging to the different. In fact, very clear can see. We saponize after entering our separation kettle. The first separation kettle will carry out the first step of the sedimentation for mixing. Add a purifying agent into the purification agent to make this porcine deoxycholic acid and porcine cholic acid. and then pumped up into our saponification kettle, forming a solid. At this time, this kettle is a solid-liquid coexistence of a phenomenon. At this time, we, after 8 to 12 hours of a crystallization state, and then into our pressure between the base of the pressure filtration, this time the solid is our porcine bile acid and porcine deoxycholic acid, the liquid is our goose, deoxycholic acid, and then the filter cake, and then through our parallel conveyor to our static kettle, and then the static kettle, and then added to the other kind of purification agent into it. The liquid is our porcine deoxycholic acid and porcine deoxycholic acid. At this time, the liquid is porcine deoxycholic acid and porcine bile acid, and then after our first floor pressure, and then press filtration, the liquid enters our acidification, kettle acidification, and reduction, and then after our pump to another press filtration basement, large pressure basement press filtration, for full solid liquid separation, and then the cake washed into our drying equipment, and at this time to get our porcine deoxycholic acid and porcine bile acid, and then back to the first filtrate then the first filtrate goes into our double effect concentration, into our function tank, and finally into our back one centrifugal spray to get our goose deoxycholic acid.
Just now, Mr. Ma introduced our porcine bile acid and porcine deoxycholic acid, which are the combination, it's both one process, is our filter presses. Then deoxycholic acid is dried by us using our spray drying to produce, so that we can realize porcine bile acid, porcine deoxycholic acid, and goose deoxycholic acid separate extraction, which is what we do in. The industry standard sets a value for porcine bile acid and porcine deoxycholic acid content inside the standard, and then designs a separate value for goose deoxycholic acid.